Cool. So I'm here presenting the Sonata project, which is a development board to enable exploring the use of Cherry for embedded applications. So I come from Low-Risk. We were founded in 2014. We came out of the University of Cambridge lab, and we're a non-profit aiming to drive adoption of open source silicon. We're a bunch of hardware design verification, compiler and software engineers. So we kind of have all the engineering that we need in-house to properly maintain all the projects we maintain, which include the big one. One of the big ones is IBEX, which is an embedded class RISC-V core. It used to be called Zero Risky. It came out of the Pulp project. It's been taped out a few times by a few people, very configurable. Do take it and play with it. And the OpenTitan project, which we steward, and many companies come and get involved and contribute to it. It uses the IBEX core internally, and recently we've had a big milestone. We've taped out the first OpenTitan chip, so hopefully you'll have open source silicon available in devices you can buy soon, which is awesome. So the too long didn't pay attention of the presentation is Chariot is a new ISA. It's a Cherry ISA that provides very granular memory safety in hardware. Sunburst is a project aimed to make Chariot accessible to developers. The Sonata system is an open source microcontroller design, SoC, to make it easy to play with the Chariot core. And there's a new Sonata board, which is an open source affordable FPGA board, which you can chuck it on and play with. So, backtracking, the problem that Cherry and all of these architectures try and solve is running untrusted software on your computer. It's an age-old problem, and when I say untrusted, I include software I wrote myself, because I write a lot of bugs. So yes, you try and give your software, you restrict your software, give it the least privileges, and you're less likely to have any problems. And yeah, I won't go on anymore. You know the problem. It was even mentioned by the White House recently. And it's kind of solved, right? We've got browsers, they're great. You run untrusted code all the time, but they're not the most ideal operating system for most things. So then we have these super restrictive memory safe languages. I really like Rust, it's amazing. You get all your type checking and memory safety checking in the compiler at compile time. So if it compiles, it often runs, which is awesome. But sadly, I still can't give someone a Rust binary and they just have to trust me that I used safe Rust. You don't have it, safety at that binary level. You're still having to call into unsafe ABIs in the kernel. And you have to trust the compiler. There's a few compiler bugs here and there, so even unsafe code can break the restrictions you want. So then we have the hardware side of things, which is actually what the browser does under the hood, right? You have processors and they all run in the MPU. And that gives you nice separation. But it's not very granular. They're very large. You do have MPUs as opposed to MMUs you can use in embedded applications. But yeah, the general problem here is it's not very granular. And a good example of this is the XZ vulnerability in Linux recently took advantage of the fact you had processors with symbols, libraries, and binaries all in the same process. So Cherry, which is one solution to kind of fill that gap in the middle, to give you granular memory safety and a bit of temporal safety. And basically, it just makes all your pointers fat. So you add loads of some information. You've got bounds, which says how much of the memory that your pointer points to. You've got permissions, which says what you can do with that memory, whether you can read, write, execute, blah-de-blah. And then you've got this object type, which allows you to kind of seal a pointer, give it to someone else, for example, a file handle, and then they can give it back to you, and you can use it, but they can't. And that's brilliant. It's a kind of an approach to adding to doing this across many ISAs. So you've got it's been ported to like MIPS 64-bit, 32 and 64-bit RISC-V, and 64-bit ARM V8s, so Morello. And of course, software is a big part of this, and they've got an LLVM compiler, GDB, and they've even got a free BSD port. And the free BSD port's very cool. It can run even non-Cherry code, so your old applications in this kind of hybrid mode. So that's amazing. We've kind of got this application class stuff. But then more recently, Microsoft came along and they made a embedded version. So they've squished everything down, and as you can tell from the name, it's targeting kind of Internet of Things. It takes away some things, but it adds a few more. It's kind of different. You can read up on it more later, but it does some clever stuff with squishing the permissions down into fewer bytes. They open sourced it, so they took our IBEX core, they added Chariot to it, they've open sourced that, they've open sourced the LLVM compiler, and since they have the University of Oxford, Google have got involved, and a new company called SCI Semiconductor are planning to tape out a Chariot chip soon to make it available widely. And then as part of that, they've also got this software stack, the Chariot RTOS, and that allows, and that really takes advantage of the full Cherry stack. So it's not porting an existing OS. It really takes advantage of this really granular memory control, so nothing trusts anything. The scheduler doesn't trust the allocator and so on. So it's really least privileges, intentionality, right down through to the OS level. So onto the Sunburst project. What are we doing? So as you've heard, there's all this amazing research that's happened. And it's all kind of, if you look at the technology readiness levels, which is, I think, a NASA thing from way back, it's kind of all been in this research phase. Amazing research has been going on, but it hasn't ever quite made it to devices and deployment. So we're trying to bridge that gap and make it really easy to develop and get through that development phase so we can get to 7, 8, and 9. So to do that, we're focusing on this Chariot core because it's embedded. There's already the Morello platform for people who want to do application class stuff, but embedded's really nice because the cores are easier to get out into the wild because they're smaller and simpler, and you've got more control of the software stack normally, which is quite nice. Yes, so it's been funded by the UKRI and the Digital Security by Design, and as part of that funding, we are creating 2 SoCs. One is the Sonata SoC, which is what I'm going to talk about mainly in this talk, and there's the Symphony SoC. So the Symphony is the big one, and the Sonata is just kind of the green bits. And the big difference is basically Sonata is nice and small and it's really easy to play with, and then we've bunged on an OpenTitan, so you can play with all the OpenTitan IP in the Chariot context and play with it as part of a bigger system. And what's even cooler is we're taking advantage of New AE, which is a really cool company. I think JP is here in the audience in the pink shirt. They make amazing dev boards that we use all the time in OpenTitan. We love them so much that I think they were acquired by Low Risk about 2 years ago. And the Symphony platform, we're going to make sure runs on their CW340. It's huge, so it needs one of those big FPGA boards. But we're also going to we're making a small Sonata board, which is going to be open source, which I'll talk about in a bit. So, the Sonata system. The main goals are ease of use, debuggability, and making it configurable. So you've got just all your standard stuff connected to the Chariot IBEX. It's all open source, as I said before, so you can add and take away stuff. We've got a pinmuck, so you don't have to touch the RTL if you want to just reroute some stuff through. We've got the HyperRAM, which is nice. So as part of the Chariot RTOS work, a big part of Cherry is being able to reuse this existing C code, right? And not having to rewrite the world in these memory-safe languages. So it's quite nice to take these big blobs of C and C++ code and try them out. So you've got HyperRAM, which you can execute out of. So you can, I think Microsoft already got the free RTOS TCP stack, and they've got a JavaScript VM that you can run, which is quite nice out of that. And it's all being developed in the open, so if ever there's anything you want to add or ask about, do. And then there's the Sonata board, which is really cool. This is open source. It's based on the RTX 750T FPGA. As mentioned before, it's got that HyperRAM. It's got an RP2040 in there to kind of control everything. Loads of LEDs, joystick switches, and LCDs to make it really nice and interactive, so you can really play with loads of any sort of application ideas you have. And we've also got Ethernet, so you can play with the TCP pack and really do the IoT stuff, and use a USB. And then on top of that, there's a bunch of extensions. So if you don't feel like soldering, you can just plug in existing Raspberry Pi hats. It's got Arduino Shield, Microbus Click, a SparkFun Quick. I don't know. I haven't used that one. PMods, and then RS-232 and RS-485. And that's going to be available starting from May from Mouser for around $400 to $500. It's all open source, as I said before, so you can edit it and build your own if you don't want to buy one from us. It's initially designed in Altium, but we've got a KiCad fork, which is coming on its way soon. And not only is it free as in Liberty, but it's also, there's some going free as in beer, which is amazing. So as part of UKRI funding, we're releasing about 100 boards for free to get them into the hands of developers. So if you want a board, do scan the QR code or follow that link there, and we might be able to get a board for you, to you for free, so you can start playing with the Chariot stuff. So yeah. So that's kind of an overview of the Sunburst project. We've kind of got these two SoCs, Sonata and Symphony. All the RTL is free. We've got all the RTL is open. We're developing in the open. We've got I think monthly technical meetings. So if you want to really get involved, you can come and join the technical meetings. And there's loads of decisions that have been made by talking to the community already. Lots of stuff on the board was guided by what the community wanted. So do get involved, do listen, and we will add stuff if you really want it. And we also have a hackathon happening in the Cambridge Computing Lab in May. I know it's coming up soon, but if you happen to be there, that'll be fun, and we'll have a bunch of these Sonata boards. I've even got some now, so if you want to have a look and play, and I've also got stickers and stuff if you want. So yes, that's everything. Please have a play. That's the link to the main website, the Sonata system, which is the SoC part of everything. And that's my email address. So if you have any questions or want to get in touch, email me. Cool.
Thank you. I think we have a question over here.
So can Yanks get the board? Because there's like one Morello board in the US.
Yanks will definitely be able to buy the board, and I think you should be able to get free boards as well, maybe. It's been going on for a while, so I don't know how many are left and available. But yeah, you'll definitely be able to buy it, hopefully free ones as well. So yeah.
So for the full-blown Cherry RISC-V stuff, they have the whole software stack and FreeBSD and all that.
Yeah.
Have you modified that, or you done your own software stack, or what's the state of play on that?
Yeah, so they're kind of big. The Chariot stuff is very, they've really made it embedded. So like the Cherry so far has mainly been application class processors, big things, and they've ported big operating systems. Chariot is very much embedded. So they've made a whole new, the Chariot RTOS. This is Microsoft. And that's, whereas in normal, when you've ported an operating system with Cherry, you're kind of making an existing operating system work. They've just got a blank slate, and they're really making use of all the features of Cherry to get compartmentalization within the operating system itself.
And the compiler toolchain and things like that?
Oh, the compiler toolchain, yeah, they forked the Cherry compiler and then added and support for Chariot as well. So yeah, so it's all building on top of that stuff.
How does the Sonata system compare to like other microcontrollers? Like if you buy this board, like how would it compare to like an Arduino board or something?
Oh, okay. So it's FPGA based, so it's kind of more like an FPGA dev board than a Arduino board, which is nice. So yeah, it's nice. It's like the RT. There's the RT boards and stuff. They're kind of based on a similar FPGA. So it's kind of like that, but with a bunch more stuff whacked on and open source. So you've got your Ethernet and all of the things, so you can just plug stuff in without having to. The idea is no soldering. People can just, in hackathons, can plug in Raspberry Pi hats and stuff, You don't even have to put the Sonata system on it. You can just buy the FPGA board. It's a really cool FPGA board. So yeah, but we developed it for the Sonata system so people can play easily.
I have a final question. What's the core score for that board?
We'll have to find out.
Thank you, Hugo.
Thank you.